A customer messaged me at 2 in the morning asking to buy 40 more mobile lines. His scraper was getting blocked and he had decided the IP pool was the reason. He asked one question before quoting him. How many requests per second are you sending? As many as it can do. I did not sell him the 40 lines. I sell mobile proxies for a living. The order was sitting there ready to invoice, and 40 more addresses would have bought him about a day. Why I get to say that? I run the proxy side of this myself. Real SIM cards on Singapore carriers, modems in a rack in my flat, about $10 a month per line in data and another $1.50 in modem depreciation. I also write the scrapers that hit my own systems, so I see the request leave and I see what it looks like landing. From that seat, the sentence I repeat most often is that the address is rarely the thing that got you blocked. The order the causes actually go in. There are 4 things worth checking when a scraper starts failing, and almost nobody checks them in this order. How fast you are asking and how regular the gaps are. Whether the request looks like the software it says it is. Whether you are holding a session or throwing one away every time. And then last, the reputation of the address. Most people start at the last one. That is the one you can fix with a credit card, which is probably the whole explanations. Rate is the one most of the time. Rate limiting is the oldest defense on the internet, and it still catches more scrapers than everything else put together. A site does not have to work out that you are a bot. It only has to notice one address asking for 900 pages in 4 minutes when the median visitor asks for 6. That is a counting problem. It costs nothing to run, and it is usually the first rule anybody writes. So the first fix is boring. Slow down. I have watched a job go from a block every few hundred requests to a clean run of tens of thousands by changing one number. The number people usually pick wrong is concurrency. They set 30 workers because the machine can run 30 workers. The rhythm matters as much as the rate. Here is the part that surprises people. 2 requests every second, forever, exactly on the second, is more visible than 5 requests in 1 second followed by 19 seconds of nothing. Real traffic is lumpy. A person loads a page, reads for 40 seconds, opens 3 tabs at once, then wanders off to make coffee. The gaps between their requests are all over the place. A scraper with a fixed sleep produces a metronome. The average looks reasonable and the variance is 0. 0 variance is a fingerprint anybody can compute. So put jitter in. Randomize the gap. Randomize how many pages you take in a burst, and stop the run entirely sometimes because people sleep and your process does not. You also stagger the start time. Every scheduled job on Earth kicks off on the hour, and that is the busiest, most watched minute in any traffic log. A client that contradicts itself. Second cause. Your request says one thing about itself in one place and something different in another place. The common version is the user agent. Someone sets it to the newest Chrome because every tutorial says to and sends it from a Python library carrying 4 headers. A browser sends somewhere between 12 and 18 in a stable order, including the ones about language preference and how the page is being fetched. So the request claims to be a browser while carrying almost none of a browser's luggage. Checking that consistency does not take machine learning. It takes an if statement. It goes below the headers too. The TLS handshake your client opens the connection with has its own shape from the cipher list and the order of the extensions, and that shape differs between a real browser and a scripting library. A server sees it before it has seen a header. I am not going to walk you through faking any of that, and faking it is the wrong fix anyway. The fix is to stop the contradiction existing. There are 2 honest ways. Drive a real browser, so the headers and the handshake belong to a browser because a browser produced them. Or send your own identifier, say who you are, put a contact URL in it, and read the site's robots file and terms first. So what you collect is what you are allowed to collect. The second one sounds naive. It works more often than people expect, especially with smaller sites, and a fair number of places will hand you the data or point you at an API if you just ask. No sessions, so everyone is a stranger. Third cause. And this is the one that quietly ruins the most jobs. A normal visitor arrives, picks up a cookie, and carries it with them. Their next 20 requests are visibly the same person continuing. A scraper with no cookie jar, or a fresh jar on every request, is 1,000 separate first-time visitors from the same neighborhood. Each one arrives with no history and goes straight to a deep URL that nobody reaches without clicking something first. That pattern needs no address reputation at all to spot. So keep the jar, let the session accumulate. Arrive at the front door occasionally instead of always teleporting to page 400 of a listing. While rotating every request is often worse. The default in almost every proxy tutorial is a fresh exit address on every single request. It feels safe. Spread the load, no one address does much, nothing to count. Against a site that tracks sessions, it is worse than doing nothing. Now you have one continuous session identity hopping between 200 addresses in different cities. No person does that. A bank would freeze your card over it. And you have thrown away the history that was making the session look ordinary. Holding one address for the length of a session, then rotating between sessions, matches how people actually browse. It is also less work to build. Rotating per request has real uses. Independent single page fetches with no state between them. Price checks, availability polls, anything where each request is genuinely unrelated to the last. If your job has a login, a basket, or a search that carries filters through several steps, holding beats, rotating, and it is not close. And only then the address, now the part I sell. A data center address gets caught on reputation alone, before you have done anything at all. The whole block belongs to a hosting company. The network number is published, and anybody can see that no household has ever lived there. Some sites refuse the entire range on principle. Your request was rejected in the second it arrived, with your behavior never examined. A residential or a mobile address usually does not trip that filter. It sits in a block a carrier hands out to ordinary phones and homes, and refusing the block takes real customers with it. A mobile address in particular sits behind carrier-grade address translation with a crowd of other subscribers, so it is hard to pin to one person. All of that is reputation. It is a filter you pass, and anyone telling you a proxy type cannot be blocked is selling you something. Behavior still gets you caught on any address. I have watched a mobile line get blocked in about 90 seconds because the scraper behind it was doing something absurd. What a good address actually buys is that the cheap first filter never fires, so your behavior becomes the thing being judged. That is worth money. It is worth a lot less money than fixing the behavior. The three ways a site says no. Hard block, a 403, a 429, or the connection simply dies. This one is honest. Your error rate spikes and you go and look. Soft block, you get a 200. The page renders, the data is there, and it is subtly wrong. Stale prices served from a cache. A list truncated to the first 20 rows when there were 400. A field that used to be populated coming back empty on every record. The middle one is dangerous precisely because your monitoring stays green. The job succeeded. The row count looks normal. And you are writing rubbish into a database and reporting on it for 3 weeks. Challenge page. An interstitial that wants proof of something before it lets you continue. That is the site saying plainly that it wants a human here. Treat it as an answer. Back off. And if it keeps happening, go and look for the official AP or ask for access. Trying to punch through a challenge is where scraping stops being scraping. How to tell you are being fed rubbish. One thing worth building, a canary record. Pick 5 items whose true values you know, check them by hand in a browser once a week, and have the job assert against them on every run. Then watch the shape of the output as well as whether it arrived. Field fill rates, rows per page, the byte size of the response. All of those move when a site starts quietly serving you something different. None of them move when you only check status codes. DMs in this order. Someone tells me their scraper is blocked. This is the sequence I give them. Open the same URL in a normal browser on your own home connection. If that works and your scraper does not, the address was never the problem and you have just saved yourself a purchase. Then set concurrency to 1 and the delay to 10 seconds and run 20 requests. If that comes back clean, you have a rate problem and the fix costs nothing. Then put the 2 requests side by side. The exact call your client makes and the exact call the browser makes. Look at what the browser sends that you do not. Then check whether you keep cookies across requests. Most people discover here that they do not. Only after those 4 does the address become a sensible thing to spend money on. And by then you usually know exactly what you need it for, which is how you end up buying 4 lines instead of 40. The 3 weeks I got this wrong. I have made this mistake myself, and I made it in the direction that would have made me money. A job of mine started failing at around the 800th request consistently. I decided the pool was too small, moved the whole thing onto mobile lines, and felt pleased with myself. The failure moved to about the 900th request. That was the entire improvement. The real cause was my retry logic. On any error, it retried immediately 3 times against the same URL. So every failure turned into 4 rapid requests, which produced another failure, which produced another 4. One slow moment on their end, and my scraper manufactured its own burst and got itself counted. It added exponential backoff with jitter, and the job ran for weeks. The mobile lines were fine, and I still use them where a real carrier address is the requirement. But I spent 3 weeks and a chunk of hardware budget on the 4th cause, because it was the one I happened to have in stock. What I still cannot solve. There are targets I have never got working politely. A few large platforms say clearly in their terms that they do not want automated collection, and my honest advice is to buy the data, use the official AP, or drop the project. I also cannot tell you what any particular site is running. I see a request and a response, and I infer, and I am sometimes wrong. Anybody who tells you exactly which system blocked you from the outside is guessing. The full written version, with the diagnostic order as a checklist and the settings I start every new job with, is at proxyscraping.org. Subscribe for more on scraping with proxies.